Welcome students for the continuation of part 2 of the evaluation of crude drugs, in which before starting this session I want to remind you that we have already discussed about this quantitative microscopy regarding the histological characteristics, stomatal index, vein islet number, stomatal number, palisade ratio. These all things come under quantitative microscopy, but histological character directly from the histology. But this is quantitative microscopy by lycopodium method to find out the number of the starch grains, number of the even foreign substances. These all some quantitative microscopy specific characters. You should have a specific differentiation you should write, because you see here why I am going to the back slide, because here which we made one denote, I think I have made here to this is all about order. Anyhow, I want to show this is about microscopical characters which we have seen, and we made here also it is the quantitative microscopy which we have discussed about this quantitative microscopy of histological features which we have already discussed in the last class about stomatal number, stomatal index, vein islet number, palisade ratio. Quantitative microscopy, we made it again to make it quantitative microscopy a word, because the number this is completely about the ratio, index, and which is in the histological quantitative microscopy features. But quantitative microscopy specifically when you want to say number of starch grain, number of foreign substances which can be determined by means of this lycopodium spore method. That is why they are made specifically at a quantitative microscopy. That is, don't net confusion. That is also we can say quantitative microscopy for histological characters in the histological sessions. And you can see this is also but this is number of starch grains, number of foreign substances which may be present can be identified in this method what we are going to discuss now. That is why specifically it is denoted as quantitative microscopy. Understand? So don't get confused. Suppose they are asking in little more wider or in explain more, if they ask, then it is necessary for the students to write about the detail. So here the quantitative microscopy, today we are discussing from the previous class, continuing about quantitative microscopy in especially the number by lycopodium spore method is one of the example. Many times they are asked what is lycopodium spore method, how it is quantitative microscopy, what type of how we can perform the experiment. Also it is needed for you to write it clearly. So it is an important analytical technique for powder drug, especially when chemical and other methods of evaluation of the crude drug fail as accurate measure of the quality. So example of lycopodium spore, this is lycopodium spore, they are uniform, and you can see this is a picture which shows to identify the trichomes, because trichomes are different, and the spores, this many spores are present in this area, and how many trichomes are present in the powder, like that there is some specification can be found out for the tribulus terrestris. Tribulus terrestris trichomes can be given a specific identity for a number of trichomes present in this lycopodium spore method can also be followed. So this is just a picture to show you about the lycopodium spores, how they are uniform, and it can be identified. Even the lycopodium spore, how many in this one area, how many, they like that 25 areas which you have to select and you have to find out. It's a very critical and very good results will be obtained from this lycopodium spore method in the characteristic shape of appearance. And see, lycopodium spore method This is an important technique employed to identify the crude when physicochemical methods are inapplicable. The powder crude drug with well-defined particles that can be counted, or the object or measured diameter can also thickness under suitable magnification are calculated by lycopodium score method. So not only starch, other organic matters, even impurities can also be identified by means of specification which is given by the standard guidance books. And adulterated starchy drugs can be determined by counting the number of starch grains per milligram and calculate the amount from the known number of starch grains per milligram of pure starchy materials can be compared and calculated. Now, what are the materials required? I am going to give you the complete details of the practical events also. It can be performed in our lab. Requirements for the practical experiment are balance is needed, watch glass, small flexible spatula, and a microscope mechanical stage is needed for moving. The area wise counting is needed, and counting square is also needed, and a suspending agent, because you should make it as a small slurry and then only it will be applied. So a suspending agent fixed oil or a suspending agent glycerin, tragagan, mucilage, water, that is a ratio 2:1:2, like that. Glycerin, tragagan, mucilage, water 2:1:2. That is also can be used as a suspending agent. This keeps the spores and the particles in a suspension. Dilution of the suspension should be given up to 10 to 20 spores in a field. That also you can observe how many spores. Simply you can observe that is 10 to 20, not more than that. Crowding is not possible for you, difficult for you to count them. Procedure: determine the loss on drying of the powder at 105 degrees centigrade, which is given. Mix the weighed amount of air dried powder of the drug and the weighed amount of lycopodium spore in a small, both drug and the lycopodium, in a small watch glass. 100 milligram of drug and 50 milligram of lycopodium spore. So very simple. What should be taken and what is the suspending agent should be added, all these things we have given. Mix with a small flexible spatula. Add the oil, the suspending agent, whichever which you select, and mix for 10 minutes, and a smooth paste is obtained now. And this smooth paste is taken. Transfer the suspension to a small glass tube, glass tube, by draining with the help of a glass rod. Glass rod, by means of draining with a glass tube and glass rod. And then you have to make the suspension to shake. Actually, it should be made into uniform. So the more suspending agent washed down, mix into the tube. For 4 ml of the suspending agent is required for 50 milligram of lycopodium spore. That is a ratio which they have given. Theoretically, we should have that. And you should swell the tube and mix the tube. That should be 10 to 20 spore viewed in a 4x objective in the microscope, not more for lycopodium. So 50 milligram for 100 milligram we are adding. So when a drop of mixture is mounted in a glass rod, that is just a given, not very much crowded lycopodium spore. It is difficult for you to identify the other substance present. So slowly oscillate, shake or rotate in between the two palms of you and without air bubbles, so that the air bubbles can be removed. And then until the suspension is uniform, you have to swirl it. Take a glass tube. Glass rod will be available in the lab. So glass tube which diameter will be 2 to 3 centimeter in diameter of glass tube. And place one, from that you can take one drop from the slurry which is prepared, or the suspending agent added, and simply a suspension which is made by you, and two slides you can keep, two observation, and spread the suspension with the in the slide, less area than the cover slip. Don't make it very big because you have to mount it by cover slip. So that square only you have to spread it, and apply the cover slip slowly by means of using a needle without air bubble entrapping. You know how to mount the cover slip and leave the slide for an even surface and to settle. So here, and you have to now observe, select 25 field and count the spores and the particles of this field using 10x and 40x magnification, 10 in eyepiece and 40 in the objective magnification. Make a similar suspension as above and count the particles for 25 field in 2 slides. 25 fields you have to count and take average of the 4 reading. Average of the 4 reading. So you have to average of the 4 reading and then calculate the percentage of foreign matter from the obtained field of average which you got. So here you see this one, I will just pull it down little so that you can see here. This I can, now it is possible for you to see. So you can see here now we have to take, especially they calculate the foreign matters present in the formula given below. Actually the percentage of foreign matter is equal to N into W into 94,000 into 100 divided by S into M into P. So I made it not to for a confusion. You should not get a confusion for that. So here also this line I should pull down just to make a denominator. So clear the formula, I made it this session. So you can see here the formula is especially you can see here N into W into 94,000 into 100 divided by S into M into P, where M is a weight of the milligram of the sample which you have taken, calculated sample dried for 100 degrees centigrade. They say 100 milligram, but we may take sometimes 92, sometimes 105 milligrams. So exact weight is needed. So that is an accurately weigh and exactly weigh. These are not approximately weighing or different words are there. But it is analytical. You should accurately weigh. Accurately weigh means it is not exact weighment. It may be high or low, but accurately you should mention the weight which is taken. W, weight of the milligram of Lycopodium spore, it is 50 milligram is said, but maybe 49, maybe 48, maybe 52 milligram. Accurately weigh. So try to understand what is the word of accurately weighing means. How much weight which we have taken for the experiment plays the major role for your calculation. Simply writing 150 theoretical should not come to the results when you are applying. N is equal to number of particles in 25 fields which you have calculated. Number of particles, number of not Lycopodium. N is equal to number of particles. If it is ginger, number of ginger particles. If it is starch, number of starch particles. Like that, number of particles. S means number of Lycopodium spore in the same 25 field. So you have to count the Lycopodium spore how many, and also how many the other material which is standard which you are determining in this experiment also should be counted. P is equal to number of the particles per milligram of the pure foreign matter dried at 105 degrees centigrade will be given by the standard books. It will be having a standard number, standard value. According to IP or BP, it should refer for you to go for what is the value. P value should be identified which is given. 94 is for Lycopodium. 94,000 number of spore in 1 milligram of Lycopodium is already given a standard value. So calculation, 1 milligram of Lycopodium powder contains spores of 94,000. W milligram of Lycopodium powder contain 94,000 into W number of spores. And S number of spore in 25 fields mixed with the N number of starch grains because we are going to find out starch grain as an example. So I have given starch grains in 25 fields. So instead of writing organic material, I wrote directly starch grains because we are doing the experiment. And 94,000 into W weight spores into mixed with 94,000 is equal into N into W divided by S number of starch grain. So 1 milligram of pure sample of foreign matter FOM contains P number of starch grains. So weight of this ginger is mixed with 94,000 into N into W divided by S into P milligram of ginger. So M milligram of mixture contain 94,000 of the value which is given for lycopodium into N, which is the N means number of the starch grains or the substance which you are using it, and into W is the weight of lycopodium powder divided by S into P. And 1 milligram of mixture contain 94,000 into N into W by S into P by M. And so the percentage of foreign organic matter, that means starch which is present, or foreign organic matter which can be determined by 94,000 into N into W into 100 percentage, 100 divided by S into P into M. So this is very important for you to know. Again I am repeating, what is this N, what is M, what is S, what is P. All these things should be denoted very clearly. Calculation here, N is the number of characteristic structure of the starch grain which you have taken as an example here in ginger in the 25 field, and W is the weight of the lycopodium which you taken. We used to take 50 milligram, and S is the number of lycopodium spore. It is in the same place which you have to count in the 25 field. M is the weight of the milligram of the same of the which you have taken of the grains which you have taken. P is the standard value of the characteristic structure. So this is a picture which I am showing the starch grains which is present in the mucoprotein line of seed which they have found out, and starch grains and the lycopodium. We can see the starch grain difference and the lycopodium strains which you can see very clearly. So this can be identified in an area, 25 area which you have to select, and in 25 area how many lycopodium spores are there, how many starch are there. That will give you the percentage of the compound which is present. So you can see that very even for the fibers, even for the trichomes, even for any other materials can also be used for lycopodium method, can be used for identifying other compounds. So the percentage purity of an authenticated ginger powder calculation example I have taken here, N into W into 94,000 into 100 divided by S into M into P into the percentage of the drug will give you. So N stands for the number of characteristic structure of the starch grains in the 25 field which you have counted, N. W weight of the lycopodium which is taken usually 50 milligram, and it goes to the 48 or 49 or 50, 60 milligram which you have taken. As I told, accurately you have to put the weight which you have taken. And S is the number of lycopodium spore in the same 25 field which you are seeing for the starch grains of the ginger. This also should be counted. And M is the weight of the milligram of the sample calculated on the basis of dried sample ginger powder in 105 degrees centigrade. In the moisture content is removed, and you have seen what is the weight of taken of maybe 100 milligram, maybe 110 or 99, 95 milligram exactly or accurately weight amount should be written. So usually P value for the ginger we are taking as 2,86,000 in the case of ginger starch grain powder. This is a P value which is given by the standard book of Indian Pharmacopoeia. So this can be used for your calculation. Can you follow me? What is P now? So P, M, S, W, N. These all things should be very clearly, should be easily you can denote, and that is why I took the time for you to explain this lycopodium spore method. Many times they are asking this question, lycopodium spore method. Explain and how to determine, how to calculate, what is the use of, what is it, only not only starch, other organelle metals can also be calculated by lycopodium method. This is a quantitative microscopy to find out the number of organelles, number of compounds, number of histological characters. Even the quantitative microscopy includes the starch, includes even stomatal index, Bain islet number, and you can see palisade ratio, stomatal number. These all are also quantitative microscopy, because quantity, number of stomata, number of palisade ratio, number of cells can be calculated. So that is also comes under quantitative, but this is specifically more important quantitative microscopy we have given, because it can given percentage, and also it has some specific value not only for starch grains, not only for a particular, because all organelle can also be calculated by this quantitative microscopy. And the determination of fiber length and width by means of using stage micrometer calibration, which you studied in the last class itself, eyepiece micro calibration, calculate the factors distance between two lines of microns, and calculating about taking the quantity of the powder of Ceylon cinnamon or cassia bark, cinchona bark, the fibers, the test tube in the boil and clearing of chloral hydrate solution, staining by means of using that is, for example, you can use fluoral hydrate or fluoroglucinol. If you are use chloral hydrate and fluoroglucinol, or HCl and fluoroglucinol, and you can find out the length and width of the fibers, transfer the clear powder into the watch glass, stain and lignified fiber stain agent like fluoroglucinol concentrated hydrochloric acid can be used. Mount and treat the powder in the glycerin water and observe the slide under the low power first, and then it can be converted according to the calibration which you made. And focus on the stained fiber by rotating the slide, the eyepiece micrometer. Note the number of divisions which is used for the length of the eyepiece micrometer, cover the length of the fiber, and again rotate the eyepiece micrometer without disturbing the slide, and find out the division of the eyepiece for the width of the fiber. And similarly, you can say 25 fibers can be counted and average can be taken, and you can find out this how many microns is used, how many microns of this length and width of the fiber can be denoted as your result. Now we are coming to the physical evaluation. Physical evaluation of the crude drugs consists of elasticity in the fibers and viscosity of the drug containing gums. Swelling factors. Swelling factor is also a factor of swelling. Mucilage containing materials. Frothing, number of saponin drugs. Frothing. This I have not added. Frothing, foam forming, and the concealed point of volatility of the fixed oil. Melting point, boiling point, water content, and extractive value. Important parameters used in the evaluation of the crude drug. So there are many. Still more which I have not. Even ultraviolet is also used for determination, fluorescence and extraction of some drugs. Ultraviolet light, that is also sometimes ultraviolet light's color change observations like what I have shown can also be used for determination of physical evaluation. Physical constants are extremely applied to the active principle of drug like alkaloids, volatile oil, fixed oil, etc. A few terms of them: solubility, moisture content, specific gravity, viscosity, melting point, optical rotation, refractive index, ash value, extractive value, volatile oil content, the RF value, and even you can see just now we discussed about the swelling factor, foam forming. These all swelling factor, foam forming, they are also added in sometimes therapeutic activity because they have some therapeutic application in swelling and the foam formation. They are used in directly therapeutic activity. That is why they may be added in even biological activity also. In some books they are added in as a evaluation. I did not add here, but I have told in the previous slide. So it can also be added as a foam index and a swelling index. These are also coming in the physical constant. Foreign matters identification like lycopodium spore method is a quantitative microscopy which can also be used for foreign organ matter. This is just an identification, that is calculation can also be done. Solubility, when you want to say, it is an evaluation of specific behavior of the drug towards solubility of the solvents taken to be considered. Crude drug characteristic solvents: colocent, light petroleum, Peru balsam and chloral hydrate, castor oil, light petroleum, half of the volume of the castor oil, and you can say even alkaloid base organic solvents, alkaloid salts, polar solvents. So like that we can just differentiate the solubility and identification can be done. Moisture content can be done by means of hot air oven, and which is the picture which I told, weighing balance, and also we need a desiccator which can be after drying the moisture, removing, it is needed to kept in the desiccator. So the moisture content of a crude drug is responsible for decomposition of the crude drug due to the chemical change or the microbial attack. It is necessary to determine and control the moisture content of the crude drug. It is determined by heating the drug up to 105 degrees centigrade in an oven to a constant weight. The crude drug moisture content digital is not more than 5% weight by weight, ergot not more than 8% weight by weight. And the specific gravity, I am just saying there are many specific gravity bottle like 50 ml, 25 ml, 100 ml, and more than that, even some of them are available even. And even picometer like that with thermometer, picometers are available, which even the weight per ml can be easily identified. So specific gravity is also referred to as a relative density, and it is a ratio of the mass of the solid or liquid to the mass of the liquid or the equal volume of the distilled water at 4 degrees centigrade, or at a gas to an equal volume of air or a hydrogen under prescribed condition of temperature or pressure. The measurement gives the idea of floatability of the drug or the bluffing floatability. For various formulations have decided this specific gravity plays a major role for deciding what type of formulation, what type of ingredients, what type of excipients, additions can be added. And the specific gravity is less than 1, substance sinks. And specific gravity more than 1, specific gravity more than 1, substance sinks, and less than 1, substance floats. And crude drug specific gravity, cottonseed oil 0.88, 0.93, and coconut oil 0.92, and castor oil 0.95. Viscosity is a liquid, is a constant of given temperature and an index in a composition of millipoise or centipoise, and they are usually Ostwald's viscometer can be used. Hence it is used as a mean of standardized liquid substance. Example, liquid paraffin less than 64 centipoise, and you can use the upper C and D. You will be using this because when you are preparing in any type of fluid, for example syrup, if you are using a herbal syrup, it is necessary for you to prepare, and after preparation standardization is the main parameter you should know about. Viscosity are very important because the flow property of any fluid or liquid orals is very important for the dosage form to be removed from the container enclosures which you have used for the preparation. So the flow property, viscosity plays a major role even for the formulation, and also to identification. It is a physical evaluation which is given by WHO. Melting point, it is one of the parameters to judge the purity of the crude drug containing lipids as constituents. They may of animal or plant origin. They contain fixed oils, fats and waxes. The purity of the following crude drugs can be ascertained by determining their melting points in the range shown against each of them. Example, cocoa butter 30 degrees to 33 degrees centigrade. This is a melting point instrument which you have a capillary tube, and a thermometer can be kept, and you can even temperature can be controlled by means of a knob automatic, and then you can see the melting by means of a eye, and there is a provision for your eye to observe the melting point, and in that case you can denote what is the temperature required for the melting or sliding of the. This is Tellis thermometer. The thermometer can be Tellis apparatus, which is having a L shape, which is having liquid paraffin can be filled with this tube, and a thermometer with a capillary tube with the substance which you are interested to find out the melting point can be filled in the capillary tube and tied, and then you are warming with the burner as shown in the picture, which will also find out the thermometer is used to find out in which thermometer the particular compound which is kept in the capillary tube melts, will give you the melting point can be identified. So this is about the melting point. And then comes the optical rotation. You know that optical rotation, polarimeters can be used. Many substances of biological origin having a chiral activity, having different carbon atom containing different molecules, which has, and when a monochromatic light falls on the of the molecules of the chiral carbon atom or chiral carbon atom, immediately they will have a rotation to the plane of rotation towards the right or left, which gives the D rotation, L rotation, which you might have studied in optical isomerism. Optical isomerism and also the optical activity of the compound can be determined by using polarimeter. Polarized light, a rotation of the plane polarized light either in the right or the left to the compound. So the extent of the rotation expressed in the degrees of plus or minus, rotation right is and the left is minus, can be determined, and this compound is optically active and hence they are optically rotation, can be used by means of polarimeter. And also we can have an automatic system which means of, usually we are seeing that is for example sugar solutions are having different optic because they have many chiral carbon atom or chiral carbon atoms in their compound, so that it can have the optical rotation can be determined. An optical rotation containing drug substances may have capability of rotation the plane polarized light of and that is dextrorotatory or levorotatory. Substance of the plane polarized light is a clockwise is rotatory, anti-clockwise is levorotatory. Measure the optical rotation helps the determination whether the substance rotate is not. Purity of the compound can be identified by means of giving the parameter like eucalyptus of plus 10 degrees and honey with plus 3 degrees, like that they will be having, and you can use this determination. Machines, automatic machines can also be used by digital parameters. And refractive index usually we used to do by Abyss refractometer or Abbey refractometer. And this meter is when the ray of light passes one medium to another medium, there will be a density difference, there will be a bending, the bend in the original pathway, that is called refraction. Thus the rotation of the velocity of the light, ration, that is the ration of the velocity of the light vacuum in the velocity of the substance is calculated by the refractive index, the second medium. So this measure the refractometer, Arachis oil, which shows 1.4678 to 1.4698. So this is the Abbey refractometer, which can be seen by eye, and also you can see our digital meter also available nowadays, and small meters which can be kept as a drop in the meters can also be determined by means of measuring, like Abbey refractometer is also available. This also comes under the physical parameters of evaluation of crude drugs. Ash content, ash value. So here the residue remaining after incineration. Incineration can be done by means of, you can see there is a crucible, which in the crucible we can keep, and it can be kept in the furnace, and also it can be kept as an, you can see there is incineration or incinerator of a known quantity of the air dried crude drug is known to the ash content of the drug. The ash simply represents the inorganic solvents naturally occurring in the drug and adhering to it and deliberately added to it also forms an adulteration. Can be identified. Ashoka 11 and ginger 6 is the normal. So you can use this the incinerator, and you can see how it is burning. It will be more than 300 and 600 degrees temperature. You can make it ash, and the ash value, total ash, and also sulfated ash can also be identified. So here the ash value determined as the ash value of useful for detection low grade products, exhausted drugs, and excess the sandy and earthy materials can be identified by means of finding the ash value. The different ash values calculated from the purpose of total ash, acid insoluble ash, water soluble ash, sulfated ash. Ash value is total ash. It is useful to detect of the crude drug mixed with the various minerals like sand, soil, calcium oxalate, stock, powder, and other drugs are different inorganic constituents to improve their appearance for their selling purpose, for their profit purpose. They may add as an adulterant, can be identified by means of total ash value. The maximum temperature used for the total ash value is not more than 460 degrees centigrade. I told 600 degree, up to that you can heat, but maximum degree allowed is 450 degrees centigrade. It is because of fact that higher temperature volatile alkali chlorides may be lost. And you see, this is about acid insoluble ash, that insertion chamber you have to keep, and then acid soluble by dilute hydrochloric acid will be added. The value of higher than total ash. The majority of the crude drug containing calcium oxalate and the whole quantity varies frequently, and therefore total ash of the crude drug vary within the wide limits of the specimen of the genuine drug. Example, for rhubarb total ash ranges 8 to 40%, and in case of determination of acid insoluble content is more preferable than that. And this is about acid insoluble ash value, that is acid insoluble ash and here it is containing acid insoluble as the for example, the calcium oxide formed due to the inserted oxalate is soluble in hydrochloric acid. The insoluble as then weighed, and this may succeeded earth matters that may usually present in the root, rhizome and leaves can be determined. Water soluble ash, it is used to detect the presence of material which is exhausted by the water, and you can see sulfated ash also by means of sample with sulfuric acid, and when you are burning it in the incineration it becomes charming, and then complete ash process you can see this is the color. So in this ash produces treating the drug with the sulfuric acid to get the sulfated salt. Presence of ash calculate refers the air dried sample. The temperature used to produce more than 600 degrees centigrade in this sulfated ash, and the crude drug ash values ginger, acids insoluble 3%, ginger total as 16%. Like that we can have different values will be given by the standard books, which will be helpful. Extractive values in crude drugs, sometimes the active chemical constituents cannot be determined by normal procedure. In such cases, water, alcohol, ether, soluble extractive values are determined for evaluation of such drugs. So example, water soluble extracts like aloe vera, alcohol extracts with ginger can also be determined and calculated in various. Then this is an instrument which is very important to know about, this Scavenger Apparatus, and we see it is not very clear. You can see in our lab also we are showing this for you, especially how it is not the Scavenger Apparatus we have studied in your extractive extraction methods. So here you can see there is a Scavenger Apparatus which has a side tube and a condenser is also connected, and where we can see the volatile substances will come and condense, and you can collect in the area of separated clearly how much volatile oil is present in the given sample can be measured, the measurement which is given in the Scavenger apparatus. So efficacy of the several drugs is due to the odorous principle or volatile oils. Such crude drugs are standardized on the basis of the volatile oil content. So weight quantity of the drug is boiled with the water, and the bottom of the flask, round bottom flask, is connected with the Scavengers or Scavenger apparatus which shown in the picture, and distill collected can be graduated, there will be graduation will be there or graduated means that is the measurements will be, line will be there. By that we can find out how much volatile oil is obtained and the purity of the sample of the crude drug can be determined. So the amount thus obtained is recorded in the tube. And you can see this is already we have discussed in the many other classes. We can see what is TLC and all. Here for the fourth semester student, you should know about what is RF value. Simply you should know it is identified by TLCs and TLC, paper chromatography. There are many chromatographies, and TLC, thin layer chromatography has been increasingly popular for both qualitative and quantitative estimation of evaluation of the crude drugs. Extracts can be RF value can be determined. What is RF value is when you are getting the spot, the picture which I showed, this is a chamber and this is a picture of this chromatogram which is obtained after TLC. The distance, there is a spot which is kept in the bottom, that is a sample which is kept a sample spot, and the spot which is shown in the top is the movement of the spot, and there will be the line in the top is the solvent which is moved up to that. And so that there is two distance, the distance from the baseline to the solvent front, distance from the baseline to the sample. So RF value refers to the ratio of the distance travelled by the solute and distance travelled by the solvent in the thin layer adsorbent. So RF value is equal to distance travelled by the compound solute, that is the spots which I told, divided by the distance travelled by the solvent, the line which is shown in the top. So that RF value will be always less than 1. So which will give you different values for different compounds, and if there is any impurities, automatically you can identify by this parameter also. So this is also can be written as an evaluation of the physical evaluation. Foreign matter evaluations, like you can see, this is the one is pure one saffron, that is impure one saffron, and this is pure phenyl and impure phenyl by mean adulterated phenyl. So foreign matters, the particles, organs are present, required to be called foreign matter identification. Even mold, insects, earthy materials, excreta, and many things will be added to as a foreign matter to the drug, and it can be sold. So garlic and saffron should not be more than 2%. So there is allowed some parameter, not more than that it should not be allowed. Other substances should not be added to the compound as an adulterant. And now the chemical evaluation, we are not going in much detail, just giving, that is why I am just not giving more time. Second class or something I will finish it with a short explanation, because this in fourth semester you have to write in a whole together, but if you need, you have to refer more in chemical evaluation. I have given many other classes in many fifth semester, sixth semester. You can see many evaluation procedures, instrumental methods are individually I have explained about chromatography, techniques, instrumental methods, chemical analysis, chemical test, and determination by means of various instrumental methods. This all comes in the chemical evaluation. Students have to refer all that thing if they have the time. But the thing is, your syllabus says very short, very wider syllabus, and this is chapter. In this chapter, you should know about what is chemical evaluation and some examples. So when you see this chemical evaluation, determination of active constituents, alkaloids, if it is present, quinine, quinidine, cinchonine, how much amount, what is, whether it is present or not, qualitative estimation, quantitative estimation have to be determined for evaluating the purity of the compound. So that is also comes under chemical evaluation. Determination of active constituents in a drug by chemical test is referred to as chemical evaluation. The following are the various methods of chemical evaluation. Instrumental methods like UV spectroscopy, colorimetry, IR spectroscopy, NMR, and there are many spectroscopies and many instruments which we are using for various identification, chromatographic techniques for isolation and characterization, identification, quantity, estimation. These all are comes in a chemical evaluation, and chemical constants and individual chemical tests and microchemical tests are also available for identification. Instruments, they made various instruments, evaluation, colorimetry, fluorimetry, spectrophotometry, and chemical constant test. These are like acid value, iodine value, ester value, and used in identification of fixed oil, fats. So these all comes in the chemical test. So acid value, ester value, saponification value, and there are many other iodine values. These all also comes in the chemical identification, chemical test of chemical evaluation of the crude drugs. It should be included in part if you want to specifically, if they ask, write about chemical evaluations. So there are instruments, just a picture I have shown here. to show you about how the chemical evaluation takes place. Individual chemical tests also, there are many chemical tests. These are tests which are identifying the particular drug, like example, Hapler test for cottonseed oil I just added, because when you say Hapler test means we should know what is this Hapler test. For alkaloids we know there are many tests, glycosides there are many tests, for carbohydrates there are many tests, for any steroids there are many tests, for tannins there are many tests. These all tests we may be knowing qualitative. But when you take Hapler's test for cotton, I was thinking I have to take this Hapler's test also, very simple test. Just I have taken to just for the student take. I have added this and an example to add this, because other tests anyone can write very easily after studying in the lab or after studying the other chapters also. These are tests which are used to carry out the slides. And you can see micro test. Microchemical test means slides. In the microchemical test is also they are observing by microscope and by means of small drops kept, and that is also crystalline formation test is also there. An example, eugenol in the cloud is a precipitated protein. Eugenate crystals can be identified by means of microchemical test, keeping a drop in the cover slip, not cover slip, in the normal slide. In that also it can be identified. So the test presence in the cottonseed oil is a Hapler's, that is Hapner's. For example, you can see Hapner's or Halpner's, you can say Halpner's test for cottonseed developed in red color, heating the oil with a solution of sulfur in carbon sulfide indicates the presence of cottonseed oil. So cottonseed oil can be also done by sulfur. Carbon sulfide indicates a red color, which indicates identification test. Just I added to given importance. Other test also. Biological evolution is a wide evaluation, including even pharmacological test. Therapeutical activities can be identified by animal study and also microbiological study, tissue culture, biotechnological evaluation. These all comes in the crude drugs evaluation. It's a wide chapter. I am giving a very brief explanation for this, because we want to conclude according to the syllabus which is given for 4th semester. Don't think that is, I have given another chapters, another explanation for another for detail about the biological evaluation. In that you can go for when you want to improve your knowledge, or you can refer more and you can study. And in this, it is employed when the drug cannot be evaluated satisfactorily by chemical or physical evaluation. This method is a response produced by the test of drug on the living system of compared with the standard preparation, including microorganisms which can be used in microbiology and biotechnology, and also animals like rats, albino mice, with getting the permission from the particular authority. It can be also used for testing various therapeutical applications and therapeutical actions. If the experimental pharmacological test can be done for this biological evaluation of crude drugs. Such activities represented in the unit of international units for their activity. And you can see indication of biological evaluation when the chemical nature of the drug is not known, but it is biological action is known. When the chemical methods are not available, then we have to go for the use of biological evaluation. When the quantity of the drug is small, so cannot be evaluated by chemically, we have to go for biological evaluation. Drugs with a very different chemical composition which have the same biological activity. So example, glycosides evaluated by the method of rats or frogs and pigeon. This is the one example I have given, and there are many experiments. Biological evaluation, chemical evaluation is a wide evaluation, and also it has individual chapters. But here, evaluating crude drugs, just I made it into conclude in a small manner. Thank you. Please refer and study more. All the best.